Right, we'll look at regression lines, so the correlation and regression topic in S1. So you, again at GCSE, you'll have been used to drawing in a line of best fit. But you never probably would have got the line in the best fit position, as it would have been extremely hard to do that by hand. There is, however, a method where we can use the data provided to calculate the the gradient and the intercept of the straight line and get an equation of the line of best fit. But to start with, I'm just going to try and explain a little bit about the line of best fit. The line of best fit is positioned so that these differences that you can see that I'm drawing are minimised. And the differences that we're looking at are called y on x differences, because we're looking at the difference between the value predicted by the line for y and the actual value of y. And this is this difference we're trying to minimise. So this is called a y on x regression line. And although there is mention of an x on y regression line in your textbook, we never in practice have to work that out. So for the y on x regression line, we're going to come up with a straight line equation, and we need again to be aware of our formula. So the easier part of the formula is the b, and the b equals sxy over sxx. And this gives us the gradient. I'll remind you what x, xy, and xx are in. And the value of a is equal to the mean of y subtract b, so we have to calculate b first, times the mean of x. And then we have the values of a and b. So a quick reminder then that sxy equals the sum of xy minus the sum of x times the sum of y over n, and sxx equals the sum of x squared minus the sum of x all squared over n. Okay, so we need those summary values. We also must remember that we need to know the mean of y, and it would be a bit daft if we forgot that when we were able to do the harder bits of the problem, and the same for the mean of x. And that is essentially all the information that you need to work out the line of best fit, a y on x regression line. Now, again, I'll just remind you that your information in the table will probably be given to you like this. You have sort of, maybe say 5 and 4. Say that the could be two measurements taken up to the number of spellings we got right in the first test and the second test. So we need x squared, y squared, and xy columns, and it would be 25 in the 16 and 20. This would continue. We number crunch our way through down to the bottom until we got the component parts that we need for the formula. So by adding up the columns, we get the bits that we need, and that's x squared, sum of x squared, sum of y squared, and sum of x y. Okay, so that's basically how you find the regression line. Final thing to remember on this topic is that you might be asked to predict a value that goes beyond the line. So for example, the scatter might be like this, and then you're asked to predict what this would indicate. Now, if we knew that the line was linear throughout, then we could make an estimate. But of course we don't know that, because the highest value we've got in the picture I'm drawing is there. It's quite possible that that could happen, or that can happen. And as we have no knowledge of how the data set behaves beyond this value, we cannot therefore make a prediction for this value here. Whereas within the data set itself, it's very quite reliable to make the prediction in that way. So in interpolation inside the line, no problem. Extrapolation beyond the data set, we're not allowed to do that. And they often test that, your understanding, by giving you a value either within or without, and to see how you respond. Okay, so do practice the questions. This is a fiddly topic. It's not difficult because it's one method, but you do need to practice with numbers and develop accuracy. It's very easy to make silly mistakes with this. So practice makes perfect.